At the end of 2026, an event will occur that could change the history of cosmonautics. For the first time in the history of mankind, several missions from different countries will be sent to the Red Planet at the same time. But the main intrigue is whether SpaceX will be able to send its Starship in this launch window. What is the launch window to Mars? This is not just an opportune moment to launch. This is the only period when interplanetary travel becomes technically feasible with minimal fuel consumption. Earth and Mars orbit the Sun in different orbits and at different speeds. Once every 26 months, the planets line up in such a way that the distance between them is reduced to a minimum of about 55 million kilometers. The rest of the time, this distance can exceed 400 million kilometers. Imagine two cars on a circular track. One goes faster, the other slower. There is only one moment when a fast car can switch to the outside lane with minimal effort, when both are next to each other. Interplanetary flights work in about the same way. Miss this window and you'll have to wait another 2 years. The last Martian window opened in 2024. The next one is at the end of 2026. And it is for this moment that all the largest space powers of the planet are preparing. Let's start with NASA. The American Space Agency plans to continue the Mars Sample Return Program, the return of soil samples from Mars. The Perseverance rover has been collecting samples of Martian rock for several years and sealing them in special containers. The task of the 2026 mission is to send a device that will pick up these containers and deliver them to Earth. This will be the first time in history that we will receive real Martian soil for study in terrestrial laboratories. Why is this so important? It's all about the accuracy of the analysis. Even the most advanced instruments on rovers cannot be compared with the capabilities of laboratories on Earth. Scientists will be able to study samples using equipment that cannot be sent into space. For example, room-sized mass spectrometers, which are capable of detecting organic molecules at concentrations of 1 part per trillion. If life once existed on Mars, these samples may contain traces of it. China is moving even more ambitiously. The National Space Administration of the People's Republic of China is preparing the Tianwen-3 mission, which is also aimed at returning samples. But the Chinese plan to do it faster, in one mission instead of several stages, like NASA. The lander will take soil samples, take off back into orbit around Mars and transfer the capsule to the re-entry vehicle. The entire cycle will take about 2 years. This is a real technological challenge. Taking off from the surface of Mars is a task of incredible complexity. Gravity there is 38% of Earth's, the atmosphere is rarefied, and fuel must be carried with you. So far, no country has taken off from Mars. China wants to be the first. The United Arab Emirates is also preparing its mission. After the successful launch of the Hope orbiter in 2020, which is still studying the Martian atmosphere, the UAE plans to send a lander. The goal is to explore the Martian polar regions and search for water ice. This is part of the country's long-term strategy for the development of the space industry. The European Space Agency is reconsidering its plans after canceling a joint mission with Russia. ExoMars, which was supposed to launch a rover with a Russian rocket, is now looking for new ways to implement it. Perhaps by 2026 there will be an updated version of the project. But the main intrigue of 2026 is SpaceX and Starship. Elon Musk has repeatedly stated that the first unmanned Starship ships will go to Mars in this launch window. Not in test mode to the Earth's orbit, as it is now, but in a real interplanetary flight. multiple ships at the same time. The cargo is equipment for the future Martian base, scientific instruments, and resource reserves. How realistic is this? Let's take a look at the current state of the Starship program. At the beginning of 2026, SpaceX has already conducted more than 10 test flights. Each subsequent launch becomes more and more successful. The first prototypes exploded on the launch pad. Then the ships began to reach space. Then we learned to return and land. Recent tests have shown successful stage separation and controlled descent. But a flight to Mars is a completely different level of difficulty. Refueling in Earth orbit will be required. Starship will have to meet with several tankers, pump tens of tons of methane and liquid oxygen, and then accelerate to Mars. This technology has yet to be worked out. The flight time to Mars will be from 6 to 9 months, depending on the trajectory. All this time, the ship will automatically move through interplanetary space. Communication with Earth will go with a delay of 3 to 22 minutes in one direction. No manual control. Only standalone systems. Landing on Mars is a separate headache. The atmosphere is dense enough to create drag, but not dense enough for effective braking by parachutes. That is why all previous Martian vehicles used a combination of parachutes, braking engines and, in the case of NASA's latest Mars rovers, a sky crane system. Starship plans to land exclusively on engines. Vertically. As it is done on Earth, only in the conditions of the Martian atmosphere. SpaceX engineers have been simulating this process for several years. A thin atmosphere means less friction, but also less aerodynamic braking opportunities. Reactor engines will have to run on methane produced on Earth. It has not yet been mined on Mars. This means that the ships of the first missions will be one-way. They will fly, land, and stay there forever. Why send ships that will not return? Because this is the first step towards creating infrastructure. Each Starship will deliver up to 100 tons of payload to Mars. Imagine several ships, each the size of a multi-story building, loaded with equipment. Solar panels. Drilling rigs for water extraction. Suboutier reactors for the production of methane from the Martian atmosphere. Residential modules. Supplies of food and medicine for future expeditions. Musk's concept involves the creation of fuel production on Mars. The Martian atmosphere is 95% carbon dioxide. Underground ice contains water. Combine these components using the Suboutier reaction and electrolysis and you get methane and oxygen. This is exactly the fuel that Starship engines run on. In theory, this means that subsequent ships will be able to refuel on Mars and return. But first we need to deliver all this equipment. And that's what the first unmanned missions are for. Critics of the program point to many unresolved problems. Radiation in interplanetary space. Lack of a proven life support system for long flights. Unknown effects of Martian dust on equipment. Power supply problems in the Martian winter, when daylight hours are shorter and solar panels are less efficient. Proponents answer, that's why the first missions will be unmanned. Robots will test the technology. They will work out the landing. The basic infrastructure has been deployed. Only after that, people. The 2026 launch window will open at the end of October and run until mid-December. The exact date depends on the specific trajectory. Earlier launches require less fuel but fly longer. Late launches are faster, but more energy-consuming. SpaceX is likely to aim for the beginning of the window, late October, early November. This gives a margin of time in case the launch is postponed due to technical problems or weather. NASA usually chooses the middle of the window. China has not yet revealed the exact dates. What happens if the launch does not take place? The next window will open only at the end of 2028. 2 years of delay. For a commercial company like SpaceX, this is a serious blow to reputation and finances. For national space programs, it's a loss of momentum in the Martian race. But what if everything works out? Imagine, several Starship ships are heading for Mars at the same time. The cameras broadcast images of the Earth receding into the black void in real time. Then months of flight. Engineers on Earth monitor telemetry. The trajectory is corrected. They check the systems. And then, landing. Live broadcast with a delay of 20 minutes. The lander enters the Martian atmosphere at a speed of 7 kilometers per second. Incandescent plasma envelopes the hull. Sensors record temperature, overloads, altitude. At an altitude of several kilometers, the engines are turned on. The ship is leveling. Vertical descent. A dust plume rises from the surface of the red planet. Soft touch. The motors are turned off. The first Starship on Mars. Then the second. Third. Each at different points selected based on the results of satellite images. Areas with access to water ice. Relatively flat surface. A minimum of dust storms. Cameras show a Martian landscape. Reddish desert. Stones. The distant sun, which shines half as faintly as on Earth. The sky is pinkish-brown due to dust in the atmosphere. The hatches open. Robotic arms begin to unload the equipment. The first steps to establish a human outpost on another planet. This is not a fantasy. This is the plan. And the starting window of 2026 is the moment of truth. Of course, there is a possibility that everything will go wrong. Rockets explode. Plantings fail. Equipment breaks down. The history of cosmonautics is full of failures. The first attempts of the USSR to reach Mars in the 60s ended in accidents. American missions have not always been successful either. Even now, the percentage of successful Martian missions is about 50%. But every failure brings you closer to success. Engineers are learning. Technology is improving. What seemed impossible 10 years ago is becoming routine today. 10 years ago, the idea of a reusable rocket first stage was considered science fiction. Now the Falcon 9 makes 2 launches a week, using the same stages 20 times. Starship is the next step in this evolution. Fully reusable system. 100 tons to low Earth orbit. When refueling, it is the delivery of cargo anywhere in the solar system. Mars is the first target. But not the only one. The same technology can deliver cargo to the Moon, to asteroids, to the moons of Jupiter and Saturn. Starship is not just a rocket for the Martian program. This is a universal transport system for space exploration. And it all starts with the window of 2026. In addition to purely technical aspects, there is also a political dimension. The Martian race is a new version of the lunar race of the 60s. At that time, the United States and the USSR competed. Now there are more participants in the game. America, China, private companies. Everyone wants to be the first. The first to return soil samples. The first to imprison people. The first to create a permanent base. These achievements have not only scientific, but also symbolic value. They demonstrate technological superiority, inspire a new generation of engineers and scientists. They form public opinion. When Neil Armstrong set foot on the moon in 1969, it was hailed as a triumph not only for NASA, but for Western civilization as a whole. The first man on Mars would have a similar significance. Only the scale is larger. The moon is 3 days away. Mars is 6 to 9 months old. The moon is a satellite of the Earth's. Mars is a separate planet. Who will become it? An American astronaut flying a NASA spacecraft with a nuclear engine? A Chinese taikonaut launching on a rocket Long March? Or a Starship crew member selected by SpaceX from thousands of candidates around the world? We will find out in a few years. But the first step is unmanned missions in 2026. The scientific community is waiting for these launches with particular interest. Soil samples can answer a fundamental question: was there life on Mars? Today, the planet is dead. The temperature is minus 60 degrees on average. The atmosphere is 100 times thinner than the Earth's. Liquid water cannot exist on the surface, it either freezes or evaporates. But billions of years ago, things were different. Mars had a thick atmosphere. Rivers flowed. There were lakes, perhaps even an ocean in the northern hemisphere. The climate was humid and warm. Conditions for the origin of life. Then something changed. The planet has lost its magnetic field. The solar wind began to blow away the atmosphere. The temperature dropped. The water disappeared from the surface. Only traces remain of that ancient Mars: dried riverbeds, layered sediments, minerals that are formed only in the presence of water. If life originated on Mars at that time, traces of it may be preserved in ancient rocks. Fossils of microorganisms, organic molecules, isotopic anomalies characteristic of biological processes. Mars rovers have already found hints. Complex organic compounds. Methane in the atmosphere, the concentration of which varies according to the seasons. Minerals whose formation on Earth is associated with microbial activity. But this is not evidence. These are clues. For a definitive answer, samples are needed in terrestrial laboratories. The 2026 soil return missions should deliver them. NASA is targeting Jezero Crater, an ancient river delta. China chooses the Utopia Planitia region, a plain where there could be deposits of an ancient ocean. Both places are promising in terms of searching for traces of life. The analysis can take years. Scientists will examine every gram of Martian rock using the most advanced methods: electron microscopy, mass spectrometry, isotope analysis, geochemistry, mineralogy. And if even one microbe is found, even if it is dead and 3 billion years old, it will change our understanding of life in the universe. This will mean that life arises wherever there are suitable conditions. That we are not alone. That the cosmos may be full of life, we just don't know where to look yet. or the samples will turn out to be sterile. And then the question will remain open. Maybe life never arose on Mars. Maybe it appeared, but it did not leave traces in the rocks that we studied. Maybe you need to dig deeper, look in other places. In any case, the 2026 missions will bring us closer to the answer. Technologically, these flights will also be a test of systems for future manned expeditions. Navigation in interplanetary space. Communication at a distance of hundreds of millions of kilometers. Autonomous landing. Deployment of equipment in Martian conditions. All this needs to be worked out before people are on board. SpaceX is planning a manned flight to Mars in the early 30s. NASA is considering the mid-30s. China has not officially announced a timeline, but experts believe it could be in the late 30s or early 40s. Whoever flew first, the unmanned missions of 2026 will lay the groundwork for it. There is less than a year left. Engineers work around the clock. The engines are being tested. They check the systems. Trajectories are simulated. Contingency plans are being prepared in case of accidents. Launch pads are being prepared for launches. In the United States, the Kennedy Space Center in Florida and the Starbase base in Texas. In China, the Wenchang Cosmodrome on Hainan Island. In the UAE, launches will be carried out with the help of partners, most likely from Japan or India. Scientific teams plan what experiments to conduct, what areas of the surface to examine, what samples to collect, where to direct the cameras. And we, observers from Earth, are waiting. We are waiting for launches. We are waiting for messages about entering the trajectory. We are waiting for the first images from interplanetary space. We are waiting for tense minutes of landing. We are waiting for the first data from the surface of the red planet. The launch window to Mars opens once every 26 months. The 2026 window may go down in history as the moment when humanity took the decisive step towards becoming an interplanetary species, or as another attempt that taught us something important before the next one. In any case, it will be unforgettable.